We're going to do a segment now that I've been looking forward to for many, many years. I have a long history with the Rybovich family, having been a mate on a Rybovich boat back starting in 1977. Michael and I have known each other a long time, and we're pleased today to be at Michael Rybovich Sons Boat Works in North Palm Beach, Florida, and we're being hosted by Michael Rybovich here.
Great to see you, Paul. We go way back.
We do indeed. We do indeed. And miraculously enough, you still welcome me back to the yard.
Yeah, I'm not sure about the definition of welcome, but
but thanks for having me anyway.
We're glad you're here.
So, Michael, one thing that's always impressed me is how Rybovich does things differently. They say that imitation is the sincerest form of flattery, and starting back after World War II, when your grandfather had the yard and your uncles came home from the war and the Rybovich name began to flourish, you guys really defined the sport fishing industry. Give us a little sense of how that all started and where that comes from.
Well, first off, our family in the business of boat building was kind of backed into by my grandfather. He actually came over from Austro-Hungary, which became Yugoslavia after World War II. Came in through Ellis Island, went to work in New York as a craftsman, a carpenter, and then heard about something going on down in Florida and what Flagler was doing down here. He came down here, went to work, but then found out in the winter months he couldn't make any noise because the Blue Bloods over in Palm Beach didn't want to listen to that racket. So he had to figure out another way to make a living. So he ended up becoming a commercial fisherman. And in his short-lived career as a commercial fisherman in the West Palm Beach area, he worked on his own boats, and all his buddies and competitors in the commercial fishing industry realized that this guy was pretty good at fixing boats. And before long, Pop had a whole lot more work fixing boats than mending his nets. And that's how he got into the boat business.
And he didn't smell like fish when he came home for dinner
well,
every night.
Yeah.
So that was a plus.
Although my grandmother, I'm sure that didn't offend her.
She was pretty tolerant.
They homesteaded down on the waterfront down there. They actually had cows and goats and pigs right there in the yard, and they were pretty much self-sufficient, as most people were in those days.
Well, and when you and I met in the late 70s and I first started working on Rybovich boats, that's where the yard was. That's where you were running the carpenter shop, I think, at that time, and I was working on a boat there. But it was at the same location as the original yard, wasn't it?
That is correct. Our old boat yard at 40th Street was on my grandmother's property. They homesteaded there in 1919, and the whole yard developed around that piece of property. If you look at the evolution of the structure of the yard, it was done piece by piece over the years.
Right, it was built on as needed.
And rebuilt several times after major hurricanes.
Which happens here in South Florida.
Right.
So Pop started with repairing other people's boats after a short-lived career as a commercial fisherman, and then the boys went off to war. So Tommy and John and your dad, Emil, went off to war, and when they came back, things changed a little bit. You got into the boat building business, if I'm not mistaken.
That is correct. When the boys got back from World War II, Pop essentially handed the yard to them and said, "It's yours now to run." They had all worked for Pop as kids, the Eastern European mentality where the best labor is free labor and it comes from family. They had all worked in the yard, but when they came back, they all had ideas about how to build the perfect boat. And as luck would have it, an old yard customer in C.F. Johnson showed up and said, "I want you boys to build me something I can catch tuna in. My only requirement is the boat be 34 feet. And so between the three of them, and especially Tommy on the design end of it, they came up with a damn good first attempt, and that was in Miss Chevy in 1947.
And that was one of the unique things about your dad and your uncles is they all shared a similar vision, And they all brought different strengths to the party. If I recall, your dad had been a pilot and was very mechanically inclined. He loved to fly seaplanes, and he was the guy who was all about the machinery and the mechanics. And Tommy was the designer, and John was business and management and customer relations, and also an integral part of the building process too.
That is true. Dad was the mechanical and electrical guy. Tommy was the artist and the designer and builder. Johnny was the front man for the business, but in addition to that, Johnny had the ability to see a need and then to create in the form of fishing accessories. So today, as you look out on all the boats up and down the dock, and you look at the helm seat or you look at the fighting chair in the cockpit, that was Johnny. And that chair is still basically his same pattern 75 years later. The aluminum outrigger, same thing. Johnny developed that. He came out of the service as a quartermaster with a lot of materials technology that he had gained.
Extruded aluminum being the secret to that.
Extruded and anodized process, and he developed the aluminum outriggers. There were an awful lot of things that Johnny, when we talk about him, we think about Johnny, the front man for the business, the customer relations, the fishing tournaments that he sponsored, but also he was the inventor of the group. In addition to that, another thing, and I don't want to downplay my dad's or my Uncle Tommy's contribution, because out of all three of them, Tommy was the designer and builder, and when you look at a Rybovich boat, it was all Tommy. But Johnny also became very involved in conservation, and through his efforts and hard work, we developed release tournaments and a real consciousness about the marine environment and our ability to either destroy it or protect it. And I think in his later years, that was probably his most important contribution.
And it was a huge contribution. I can tell you that I remember being around the industry after the family had sold the yard. You were still involved working here, but your Uncle Johnny, most especially, being a great ambassador for the industry, for stewardship, for conservation. And while people don't view the sport fishing industry as one that embraces conservation entirely too well, I think he made great strides in that effort. And today we have, as you mentioned, the release tournaments and a sporting foundation that tries to do as little harm as possible while still encouraging great sportsmanship and great sport itself.
That's absolutely correct. I mean, it's, as in any sport, especially hunting, it is the predator that protects the prey and the environment in which that prey can thrive. Otherwise, there'd be no sport.
Right.
So
right.
I think that was really important. All three boys, as you said, Paul, had a unique contribution, and in that lay the magic of the Rybovich mystique.
Well, speaking of the magic, so there was an evolution in the way the boats have been built over the years. Initially, it was a plank on frame, if I'm not mistaken, and then we went to a cold molded style. Today's technology and advancements in materials have given us the ability to adhere to some old traditions, but still utilize some of these new technologies to enhance and improve the products. Why don't we take a walk out into the yard and see where the magic happens?
I think it'd be great.
Awesome. Let's do it.
Let's head out there.
Okay.
Michael here, founder of Concord Marine Electronics. I've got a lot of customers that ask us how it is we've been in business for over 32 years. And you could take a look at our glowing Google and Facebook reviews for yourself. But our customers tell me they come back because our proposals are so accurate and our service department is second to none. And on top of that, we've got the technical depth to handle any problems that might come along. We're proud to announce that we've just opened a new location at Lauderdale Marine Center where we're closer to our customers for better service. So when you or your customers are ready for electronic systems completed on time and on budget, call the experts at Concord Marine Electronics.
All right, Paul, we'll walk over here and take a look at the new hull construction.
Okay, and we're going to start with where it all begins, and that's with a keel being laminated up, if I'm not mistaken.
Well, we'll take a look at it. The boys glued it up a few days ago.
Okay.
And right now, they're cutting laminations to glue up the stem.
Okay. So,
Watch the step.
I got you covered. Oh yeah, we get the planer going. That's always good for audio.
What you see here is a keel for a new 70-footer, hull number 9.
So this is where it all
laminated
begins.
8-quarter mahogany. Here.
Okay. So 8-quarter is, it's the thickest material you can really source, isn't it?
8-quarter,
On a regular basis?
No, we can go bigger. You can actually get up to about 16-quarter.
You can, okay.
This
so
is
16,
our
that'd be 4 inches.
main construction lumber in building the cold molded hulls, which is the Philippine mahogany.
Okay, and that's been the tradition since the early days, the beginnings.
It's actually,
is the
we
Philippine.
would credit Chris Craft for bringing that into the recreational boating.
Okay.
Their boats were Philippine mahogany on frame, and I think pretty much everyone that came after Chris Craft stayed with that because of the flexibility of the Philippine mahogany. It's strong, it's light, it has a good resistance to rot. You can do so much with it. So we're still using it in the basic hull construction. You'll also see a lot of composite material being used along with it. We still believe in the wooden hull because A, it gives us design and construction flexibility that we wouldn't have if we were married to a mold.
Right.
We can make little subtle changes on every boat without getting into too much modification to something that's already been predetermined. And we also have the advantages of the cold molded wooden hull, which are vibration absorption,
Sound deadening.
sound deadening acoustically, and also just that solid wood boat ride.
And lightweight and strength.
Much lighter.
All together.
I'll give you an example.
Okay.
We have been fooling with composites for quite a while, and we've built several of our deck houses out of composite. The last deck house we built was for a 73-footer, hull number 4, out of composite. And we weighed that when we picked it up and put it on the boat. And that deck house with the framework for the flying bridge was about 5,000 pounds on a 73-footer. And that was with cord infused glass composite construction.
Okay.
This deck house that we just set on this 82-footer we built out of Philippine mahogany with the bridge on it, and it was 3,800 pounds.
That's amazing.
Bigger deck house, bigger boat.
Lighter weight.
Lighter weight.
And just as strong.
Just as strong. There is a tendency to shy away in the industry from wood because people are worried about the deterioration of it if it's not properly maintained. But the truth is these things are encased in fiberglass inside and out. So it's essentially a wooden core.
It's a core, exactly.
Yeah.
So instead of having a polyester core or an epoxy core, some expanded material, some synthetic material, you're using a natural material. And that natural
correct.
material, you know, Michael, you mentioned cold molded, and while I understand what cold molded is, there are huge fallacies in the industry as to what does cold molded really mean. We've got a hull that's upside down over here that is the personification of what cold molded is. This is a keel section here that will be the basis for the boat, and from that will be our cold molded hull form that it lays into our jig, and then we do our cold molded planking arrangement. Can we go take a look at that and explain how that
Absolutely.
process works?
Absolutely.
Awesome. Okay.
So if you watch your step, we'll come across over here.
Be careful of the rails. And the door skin.
Now you're going to have to do a little crawling, Paul.
I can do that.
You want me to call your orthopedic?
No, we'll call him after the fact.
Okay.
We're never proactive on good stuff like that.
Come on up here.
Okay, so now we're inside the hull.
You are in the hull.
She hasn't been turned over yet. She's
No.
still in the construction process. And this gives us a great opportunity to look at the diagonal planking. And Michael, tell us how you build cold molded, what that means.
Cold molded is a term that's applied to laminating over a jig with the wooden construction. Most boat builders today that are still cold molding are cold molding with sheet plywood.
Okay.
Generally a Kumi plywood, which is a very strong, lightweight, essentially Luan type plywood. We still cold mold with solid Philippine mahogany. So it is not a plywood, it is 3 layers of 5/16 solid Philippine mahogany. And we do that because we feel like we can control the end result better. We're not worried about gaps in the laminations of the plywood from the plywood manufacturer. We're not worried about delam in those laminations.
So you're literally making your own ply, if you will.
Well, essentially out of very heavy laminates.
You take a 5/16 and you put it across the jig at a diagonal, and then you take the next layer of 5/16 of solid material and you put it, is it perpendicular to the initial, or is it 60 degrees to the initial? Or depending
We try
upon
as
where?
much to get 90,
Okay.
but there's a variance there in the length of your stock versus the dimension of the side of the boat. So you can tilt it a little bit either
You can
way
adjust it a little bit.
to be the most efficient with your material.
And then to affix the two together, what we do is we slather the first layer with epoxy. We attach the second layer to that mechanically, right?
That is correct.
So we use a nailing or screwing
Well,
process.
in the initial days of my family experimenting with this, we bronze nailed the laminations together. What we found is that's really a waste of time because the nail is essentially just a clamp. Once the epoxy is cured, there's no need for that fastening anymore. So now we're using screws and washers, and they're just temporary, and we pull them all out.
Okay? And the
we're
fact
done.
of the matter is, the adhesive is actually stronger than the grain of the wood. If you try to separate two pieces of wood that have been adhered together with the epoxy, you're not going to break the epoxy, you're going to break the grain of the wood.
That is true 99% of the time. The only variable is if you have bad product or someone has mixed it incorrectly.
Okay?
But if everything lines up, you're absolutely right.
And do you test a batch before you go ahead and do it, or is it just through years of experience of mixing the products, you know the consistencies, you know the mixes?
We stay with the same product.
stay
We
with
have
the
been led astray before and gotten into trouble.
Okay?
And so that's why we stay with what the materials that we've been using for the last really 60 years.
So prior to the process where we are right now, there would have been a jig or a plywood bulkhead here.
That is
And there
correct.
would be notches cut out of that bulkhead where the keel, the chines, and the stringers would be, which give you your structural integrity.
That
And
is
then
correct.
across them at a diagonal, as you can see in the planking here, across them at a diagonal, you put your first layer on and it's affixed to the structural members. And then your next layer goes on and it starts to give you some rigidity. And then your third layer goes on, so 3 layers of 5/16 gives you 1/16 inch short of a full inch. of hull
Actually, it's
thickness.
about an inch because of the thickness in the glue.
Okay.
And then we glass that inside and out.
Okay.
The total thickness usually ends up about 1 1/8 inches with
So-
fiberglass on both sides. But this section that we're in now, the jig stations have all been removed, and it really gives you a good look at the self-supporting structure that we've laminated in place here.
And the volume that you're able to create with no obstructions.
No
and that's
frames.
because all your structural integrity doesn't come from bulkheads, it comes from the form of the hull itself,
That's right.
and those diagonals being affixed to each other, fastened and glued. And then talk to me briefly about, you say you fiberglass the outside and the inside, but we don't use a polyester resin for that, do we?
No, we're saturating the cloth in epoxy.
Okay.
The polyester on wood attempts were made early on in the industry, and it was soon discovered that polyester will let go.
Because even if good kiln dried wood doesn't remove all the moisture.
Well, it's not only that, the polyester in time, like if you go take a hammer to an old Corvette, it's going to shatter.
Don't do it with the guy who owns it
Yeah.
around.
But that's what happens. The stuff is in a continual state of curing.
Okay.
Where epoxy, after about 7 days, that's it.
It's done.
And it is a much better adhesion and long-term strength. So everything now when we glass a cold molded hull is done with saturated glass with epoxy.
Okay.
So you can see that if you walk up and look at you're seeing through the fiberglass here, because the fiberglass has been saturated and the fiberglass becomes opaque, and you can see the diagonal planking.
The grain of the wood.
And you can see how tight the boys get all that stuff on each layer. Then the jigs come out. What's left, as you said before, are the structural members, the chine, the deck clamp, battens, the engine stringers, and then the structural bulkheads in the forward bilge, which give us our strength up here when they shove the throttles ahead and it's bouncy out there.
And then you utilize those spaces for tankage or
That's
storage.
exactly
as the
right.
case may
You are
be.
looking straight up into the water tanks here that are connected with the limbers.
Right?
You have your holding tank here, and then these two areas are lube oil tanks. These are integral tanks, the holding tank and the water tank, all glued and glassed in epoxy resin. The lube oil tanks will be aluminum tanks.
So the engineering component of that is that the tank actually adds to the structural integrity.
The tank stiffens the hull.
Okay.
And you can see we keep them right down the middle.
Right? Well, for balance.
Well, yeah, for trim, but also that's the strongest area because the keel's running through there along with your inboard engine stringer. So it gives you an extreme amount of strength and you don't have to worry about a tank coming apart on you.
Right. It's part of the build. And you can see the keel here in the hull form.
Yes, you can.
Where it goes underneath the tank. When the hull is flipped over, it'd be underneath.
And what you're looking at here is our gray water tank, which has been glassed in. We're waiting to come in and glass the outside of it.
Okay.
That's essentially a big shower sump.
Right. Okay. And that keel is the component that we saw the beginning process
exactly
laying
right.
on the floor in the other bed.
That is a laminated 6x8 keel.
Amazing strength. Very cool. Okay, so here's a hull that has yet to be turned over. So the next process after finishing out this segment is to move it out of the shed, bring in the cranes, hope and pray a lot that nothing goes wrong, very carefully turn it over, lay it in its support structure, then move it back into the building, and what we'll do is we'll start to construct the interior, we'll put the house on it, and we have another boat in the next bay over that the house has just been put on, if I'm
That
not
is
mistaken.
correct.
So we'll go over and take a look at
All
that.
right. Got an 82-foot hull here that we just put the deck house on.
Okay?
So you'll see when we get up there how the deck house looks. All that tongue and groove mahogany has been all covered up now
Okay.
with fiberglass.
So the hull came out of the shed, got flipped over, moved back into another bay, and positioned. And we did several of the interior lower deck spaces construction. And then once we move that material in there and have a lot of that finished, we bring the house over and set the house in place.
That's right. Set it on with a crane.
Okay.
You're staring down into the cockpit area now, in the mezzanine area. As you can see, we're using all kinds of composites in here. This you'll see Nidacor and Cusa and some Corcel throughout in here.
And those are substrates for your teak decking.
That's right, and we've gone to that to essentially get the lightest thing we can get.
Okay.
We've got our cold molded hull. Now we start going to these lightweight composites
Okay.
to pull the weight out even more.
Right.
Because
keep it light, keep it fast, keep it fuel efficient.
keep it fuel efficient.
But hull form is where your ride comes from.
That's right.
So we don't need weight
That's right
to make
down
us
in
run. We don't need weight to make us run well offshore. We need hull form for that.
That is correct. There is a misconception that you need to build a big ass heavy boat to get it to ride right.
That was the Hatteras of the 70s, right? We don't know how much fiberglass it needs, so put a little more in.
Johnny Morse is going to fix all that. And I'm proud of him. I
Absolutely.
hope he does.
Good for him.
I hope he does.
Oh, good for their group, yeah.
So we built the deck house on the ground over a jig station just like the hull. These are the tongue and groove sides. Of course, now they've got fiberglass and primer on them. We just set it on the boat, so the glass boys are coming now and they're going to tab it all down.
Okay.
We tab it to the boat inside and out. You can see the structure with the deck beams, laminated deck beams in the overhead.
So by doing it the way you do it, it becomes an integral component. It's not fastened. It's actually it becomes a part of.
It is.
Because it's tabbed. It's tabbed on the inside, and then there's a tape that goes all the way along this side on the outside.
That's right. And actually what you'll see, Paul, is we're going to fiberglass the foredeck, and we'll put the foredeck glass on here and bring it right up,
So it
which
becomes
is
a
why
part
that
of.
area is ground back.
Sure. And this will be a teak covering board here.
Yeah, but these days
We start them back there.
we're bringing paint back far enough to get our fuel fills and our tower in there to keep that out of the teak. And then when it comes time to change the covering boards, you don't have to fight with all the wires that are going up the tower leg.
You know what else is nice about that? As a mate, you spend less time on your knees sanding teak covering boards. You get to be able to stand in the cockpit and do it.
And truth be known, the real factor that drives this line of paint before you get to teak
Material.
is we cannot get the stock in the long, wide lengths anymore.
Right.
It's crazy in the teak world right now.
So that's another whole conversation about plantation teak, old growth teak, accessibility, prices, Myanmar. There's a lot to be
There's
said
a lot
about
going
teak.
on, and most of it is politics.
That's the way of the world.
Yeah. In here you can see the structure of the deck house, which, as I said, we built on a jig. Laminated deck beams, the fore and aft structural stiffeners, and then you'll see the Corcel boxes. There are 4 of them up there. That is the air conditioning plenum system for the salon.
Okay. So that's the feed for your air conditioners. It comes from the blower motors at the air handlers.
The air handlers will be up in behind the windshield. They'll blow into that and blow down.
Okay. All right. And then the fore and aft support stringers there have holes in them because there's no need for the extra weight. You continue to have the strength,
That is
and it
correct.
gives you a way to chase wires too.
Both are correct. We save weight, and the boys can run their wire runs right through there, or their plumbing run. We talked about tabbing the deck house.
Yeah.
John's over there tabbing the inside right now.
Okay.
You can see that these side decks are set up on a temporary, very simple jig.
Right.
As soon as he gets that tab, this will become one big long stiffener, and we'll take that jig out and we'll be open all the way to the side of the hull.
Okay. So actually the hull side acts as a support beam for the covering board, for the side deck.
The deck house sides do. Yes.
Yeah.
That is one big strong back running through there.
Interesting. Now, back in my day, Michael, this used to just be a window.
Yeah.
Things have changed a little bit.
Things have changed.
This is cruise quarters now?
You could fit a lot of crew in here. The industry and the way we look at boats now has changed. And actually, if you remember back in the 70s, we built a boat called the Swamp Fox.
I worked on it.
And that boat was the first one to be built with the windows filled in because the man wanted upper galley cabinets.
Out of English brown oak.
English brown oak is right. It's built for a guy named Buck Fulp out of Edisto Beach, South Carolina.
Direct descendant of Sir Francis Marion, hence the name Swamp Fox on the boat.
That is correct. Swamp Fox was the first boat that we did where we filled in the window and built upper galley cabinets. And since then, it has become a constant struggle to keep the black mask, because everybody paints this to look like a window,
right,
because the boat looks better that way.
Sure, it lengthens the line of the boat.
It continues the line all the way around. The problem is that the heat created by the black color plays hell on whatever is underneath the paint.
Absolutely.
So everybody's been fighting the cracking, the checking, the delam on the black mask, and it's still an issue. So a while back we decided, let's build a boat. Even though we can't see through it, let's put real glass all the way around.
Okay.
So we've been doing that on quite a few boats now, where we'll go from this window post
right
all the way around with glass. Everything back there you'll be able to see through. This is blacked out. Now I get a permanent high gloss actual glass finish that does not crack, check, or delaminate.
And what kind of a glass do you use for that? Do you use a tempered glass, a safety glass?
It is a very, very special high-strength glass that we get from Viravere in Italy. And they'll come, as a matter of fact, they're coming the end of this week to digitize this window rabbit. This is another thing that's a little different in the way we build it. Most of the guys now are building their deck houses on a jig, just like you'd build a hull. And all of this stuff is laminated. And then they come back and draw a line on it and paint the black mask around there, which is fine. What we've done, again, is get rid of the fiberglass black mask, which is inherently a problem. We've gone to real glass. In doing so, we built it like we built the old school with see-through windows.
Right.
We just go on this window rabbit with real glass all the way around. So
and what do we do on the back side of the glass?
It is blacked out.
It's just blacked out.
It's blacked out. Then we leave a 1-inch airspace.
Okay.
And then we go on the back side of that with composite.
Okay.
And we get that insulating factor, and the 1-inch airspace is vented, just
for
like on an airplane
contraction.
window.
Sure.
So we don't have to deal with condensation.
Right. And with today's composites and sealants and adhesives and all the advances in technologies, we're able to put glass in here that won't leak, which years ago, that was another issue we always had with windshields, was them developing leaks over time.
Yeah, and the problem back then was more with the acrylics, because we built our corner windows out of plexiglass.
Right.
And because of the thermal expansion on an acrylic, you know, it's a 1/4 inch bigger in the middle of the afternoon than it is at midnight.
Sure.
And so the stuff is moving all the time, and we couldn't find a caulk that would ever hold on long enough.
Right.
Now we've gone to real glass.
We've solved the problem.
And the new silicone-based adhesives are far better at stopping leaks. One little side note on leaks. A lot of leaks in the windows are not caused from a bad installation. They're caused from negative air pressure in the deck house, from not enough engine ventilation with these high horsepower engines that need this air to breathe. They're going to get that air wherever they can. And I know you've been out on a boat where if you're hooked up running at cruise and you open that salon door, if you don't hold on to it, it'll suck it right shut. Well, that's also trying to suck air right through the window rabbit.
Well, in the old days, before we understood the balance between the inlet air and the air that the engines needed, we had a soot ring around the carpet on the hatches.
That's correct.
Because, like you just said, those engines are going to get air one way or another, and they'll get it from any place they can find it.
Yep.
A vacuum.
They suck.
Yeah, they do. They do. No doubt about it.
So what you see here is the foredeck was put on, the deck house is put on, now we're getting ready to glass all of this.
And the foredeck is a mahogany ply.
This is the Akumi ply that we
This is the
that we
Akumi
talked
ply.
about.
Okay. Perfectly suitable for the decking material.
Absolutely.
Okay.
It's-
Good and
it's
strong, solid.
strong.
And it'll be epoxy coated.
And it's stiff, and it gives us, when we bend it around that camber, a very, very stiff foredeck surface.
Well, the strength is in the curve.
That's right.
In most of these applications, and a lot of people don't realize that with a curve like this or a curve like this, you just added to the strength, not just a strong back like that, but curvature and the principle of an arch.
That's why you see the camber in the top of the deck house.
It's all about strength.
Because that is a one huge clear span area in most salons now. It's clear span.
Sure.
So there's no vertical support in there.
Right.
So you have to throw that camber in there to get it stiff.
It's a section of a circle.
All right, you want to jump
Okay, well,
inside?
let's go inside and take a peek.
Sure.
So we've made our way into the cockpit, and there are a lot of changes and advances that we see right here. As you mentioned earlier when we first came up to the boat, we're using Nidacor for the deck support system, our underlayment for our teak.
We are.
What's Nidacor all about?
Nidacor is a polypropylene honeycomb material that you can soak in water from now until the end of time, and it's never going to come apart on you. We started using it, I would say, about 25 years ago, because all of a sudden the marine fir plywood that we had used traditionally for years and years as a deck underlayment was not the same. Something had changed. Well,
Okay.
what we got was fast growth fir.
Oh, okay. That's
Which
not going to
meant-
work.
It was no more a dense, dimensionally stable material. It's fast growth. So the growth rings are very far apart, a lot of water to get them to grow like that. It creates a very soft, almost like spruce instead of fir, and it soaked up water and it became a real problem. So quickly we needed to find an alternative. What we found was Nidacor, which not only gave us the peace of mind, but we didn't have to worry about what was under the teak anymore, but we also saving weight and getting a stiffer deck out.
Super light and super strong.
Yep.
So advances in technology
So
again.
you'll see the Nidacor out here. We're going to cover it up with veneer and a lot of paint, and it'll end up being a high gloss finish. If you look at this bulkhead, you're going to see a lot of what we're doing now is all CNC cut.
Right?
So you can see that my son, who is the engineer on all this right now, sends a file to the CNC machine guy, whoever that may be, and they cut all of this stuff according to the digital file.
And
These
it's
are what you
numbered.
call dog bones because they look like a dog bone, but that is kind of the conventional way of cutting this stuff on a 5-axis router so that it all goes together. We can't do a traditional shiplap because of the variance in the plywood when it's sitting on the table and the cutter. You could end up with variances in your shiplap. So if you turn that 90 degrees and cut it like this, you don't
It all
have a
fits
problem.
together perfectly. And it comes from the router, numbered, so it goes together according
That's right.
to a plan, and it's perfect when you get done.
Digital file is all numbered. Here again, you
lot of
see
things have changed.
John's tabbing in deck house sides.
Right.
That means tomorrow that whole jig can come out of there and should
Okay.
be stiff as a
And
church.
that's all supported from above and from the strong back.
That's right. What you're looking at there is the inside of the hull.
Right? That's that area that we painted upside down.
That's right.
Okay. All right. It all comes together.
So this is what will become the galley.
Right.
And then ahead of this will be the electrical room in here. And all our distribution will be in custom panels here and the AV equipment outboard.
Okay.
Behind this bulkhead that's not here yet will be storage and a lot of air conditioning and ducting.
Okay. And that's what feeds the
That's
air
what will
conditioning
feed
in here.
those core cell plenums.
Perfect. And that's clean and neat and out of the way. And of course, putting the air conditioning in the overhead is the right way to do it because cold air falls.
That's right. It's the best place to put it. Watch your step coming down. Down here you can look up and see the structure of the foredeck. You have these scarfed Philippine mahogany carlins that run fore and aft on 12-inch centers.
That gives you your strength.
And that gives you your strength. What you're looking at here are temporary molds that we put in. When we frame and laminate the foredeck, we need these temporaries. As soon as we glass the foredeck and get it fair, then we'll take these out.
Because then everything up there is stiff and formed, and this is no longer doing
That's
the job.
right. This was just there to construct the shape. This is master stateroom,
Right.
master head and shower around the corner. All of our joiner work you see is covered up. We built this all on the bench. It's already done, it's already varnished, it's ready to go. So it's in the boat, we put it all in before the foredeck went
It's easy to
on.
access.
This is something else that it took us a long time to figure out.
Instead of building
It
it
was
stick
a
by
whole lot
stick in
easier
here.
to do it that way. We drop it in, fasten it in place, and then put the foredeck on. In
Cover
the
it
old
up and
days,
protect it.
we had the foredeck on, and then we came down here and started putting bulkheads in.
Started carrying lumber down here
Yeah,
over your shoulder and building the components. And then when that's all done, we sand it, we fair it, we prime it, we paint it or varnish it. Instead, this is all done in a controlled environment, put in place and done.
Yep.
So it's time effective and your finished product is better.
it is better because we can build this all where we can see and feel it a whole lot better.
In a controlled environment.
Around the corner, head vanity, upper head vanity. Around the corner, master shower.
Right?
Big hanging locker here. As we go forward, washer dryer going in here.
Okay.
There'll be one more step here, but this is just the way we built the forward deck when we were putting the bulkheads and furniture in. Twin berth guest staterooms, port and starboard,
And then a VIP guest forward.
and then a VIP forward. No, that's okay, Roberta. You can stay right there. We don't want to stop the working gal.
So we've got a 4 stateroom, 3 head or 4 head?
4 stateroom, 4 head.
4 and 4.
Actually, 4 stateroom, 4.5 head. It's got day head
But
and
you
the
got
back
a
of
day
the
head
deck.
aft. Okay.
Yep.
All right. And engine package in this boat will be 2,600 horsepower MTU M96s.
16s.
So cruise speed about 37, 38 knots with a
Yeah,
top
this
speed.
boat will have a top speed of right around
Classified.
50
That's
knots.
classified information.
Yes. No, well, we can tell you. We got the last one to go 50 knots, so
That's toting the mail. That's breaking the sound barrier right
we're
there.
trying to pull some more weight out of this one,
Okay.
which is the key.
Amazing.
We've got a really good running bottom. We're not messing with that too much because we love what it does. So we're pulling weight out now.
And what's the gross weight of the boat full of fuel when you're all done?
This boat is going to be about 120.
About 120,000 pounds. So production boat in fiberglass would be another 20, 25,000 pounds?
I think that's being conservative. Yeah.
Maybe 160,000
Yeah.
at the end of the day?
I think more like
So
that.
they're big, heavy girls, and it takes a lot to push them around,
Burn more fuel, make a big hole in the water.
right?
And don't get me wrong, I mean, the production boats have their place.
There's some amazing stuff in the production market, no
in,
doubt.
in sport fishing, they do. This is what you get after you've gone through that part of your life.
This is what you get after 70 how many years of figuring out how to do it better every day?
Oh, and I'm talking about the customer, you know, after he's had enough of that and learned his likes and dislikes, Then he's ready to step up. Now we can give him exactly what he wants.
Well, he gets
because
more of his likes and less compromises.
yeah, and we start with a blank. I used to say a blank sheet of paper. Now I say a blank screen.
Right.
And from here we'll go up and see my son, who is, I'm sure, busy on,
Dusty's
on
busy
his
designing the next
screen
one?
right now.
Excellent. Well, let's go up there and take a peek before we wrap up.
Let's do it.
Thanks, Michael. So, Michael, we've talked about materials, we've talked about construction techniques, we've talked about a lot of things that set Rybovich apart. But in the old days, of course, the thing, as you mentioned to me, we started with was a clean sheet of paper.
Well, let's
How
take
are
a
we doing
look
it now?
Take a look. Now we start with a clean screen.
We start with a clean screen.
come on
Okay.
in.
Dusty, how are we making out?
Good.
Good. So all the design work is done here.
Dusty does all the design work. This is my son, Dusty, and he
Okay.
does all the design and engineering now. And then, of course, along with that, has to put up with me.
Which is what he really
It's a
gets paid for.
full-time
The rest
job.
of this is fun.
Yeah.
So,
So you can see right here on the screen, he's working on systems in everything that we're building right now, all 3 boats.
Okay.
He's got electrical on the left-hand screen, and then he's got kind of a cutaway view of the machinery space on hull 7 here.
so we're able to drill down to the most intimate detail on systems, on wire runs, on plumbing, on whatever we need to do. We've got it all computerized instead of doing it on a piece of paper and then having to interpolate that. We do it in the computer. We can actually visualize what we're doing.
That's probably the biggest advantage, is you can see it before you do it.
Okay. Do we have the ability to analyze things with the computer drawings now through naval architecture? Can you analyze performance characteristics?
Sure.
Okay, fuel burns, things of that nature.
Absolutely. It's not, you get a really good idea for what the performance of the boat is going to be, but the precision in the computer prediction, performance prediction isn't there yet. It's getting better all the time. And the stuff they've got now is very impressive as to what we had 5 years ago.
Okay. So it's really made a change. It's really made a difference
Sure.
in our planning process and what our expectations are going to be with our finished product. And then, of course, this is all memorialized. So 15 years from now, when a light fixture decides it doesn't want to work anymore and it's the fixture itself is working okay, we can trace back through the digital files as to exactly where the wire run is, exactly what wire it is, exactly what breaker feeds it.
And then we find out that they quit making that fixture.
Of course.
Yeah.
But the good news is they now make 40 matching ones that you can put in because you can't have one
It's
that doesn't
all
match.
like a quarter-inch different hole.
Yes.
And it's a smaller hole, not a larger hole.
Exactly the same almost.
Except
Yeah.
a little bit different.
Yeah.
Well, what we've learned today about Rybovich has been fascinating. You know, Michael, it's been a passion of mine ever since we were young men.
I know, Paul. We go way back.
We do,
and,
we do. I love the boats. My father was a fan of the Rybovich product. He used to bring his boats to Rybovich in the winter from up north during the summer to have them serviced, and this is where we would keep the boats. So it's a joy of mine. It's been a pleasure to come and visit with you guys. Dusty, it's great to see you carrying on the tradition, and we expect to see it for another 75 years to come.
I sure hope so.
Absolutely.
Yes,
Well,
sir.
we're ensuring that legacy from the rumors you told me.
Yes.
Good
Yes.
deal.
Yes.
Good deal.
Successive generations of idiocy.
It's a genetic trait. I love it.
You know, this ability to see it before you do it, if you and I had that years ago, we'd probably never gotten married.
If my parents had that, I'd never gotten here, that's for sure.